What's up? How are you doing this awesome Tuesday evening? Awesome background, right? Look at that. Whoa, meteor showers and all. Where have you seen this sort of thumbnail before? Do you guys like it? I saw some people in the comments saying कि आपको अच्छा लग रहा है thumbnail. Anyway, yeah, आवाज आ रही है? Are you able to hear me and see me clearly? By the way, I've started pinning this comment which has that sheet. That has all the videos that I've made so far in the recent past. एक साल में, 1.5 साल में जो भी है. You can check those out if you're looking for any specific theory sessions. हम लोग का goal अभी है to figure out things for the April attempt. In that regard, हम लोग JEE के Exemplar and Advanced की तैयारी कर रहे हैं. Right? That's the focus right here. Now, if you want to do just JEE की तैयारी, specifically, I think you should check out the sessions on the NEET channel as well as the JEE channel. आज हम लोग बात करने वाले thermodynamics की. I've done a lot of thermodynamics on this channel and the other channel as well. Here you go. This is the whole timetable जो हम लोग follow करने वाले हैं. You notice that यहाँ पे JEE और NEET दोनों है. If you have time, I strongly suggest that you check out both the NEET and the JEE sessions. क्यों? क्योंकि देखो वहां पे मैं सब्जेक्टिव सवाल कर रहा हूँ एनसीईआरटी एक्सरसाइज के, यहाँ आपके साथ मैं कर रहा हूँ एग्जाम्पलर एज वेल एडवांस की तैयारी. So for JEE Main, both the sessions are definitely useful. For JEE Advanced, I think what we're doing here is more than sufficient. Okay, these are the dates. If you want the actual timings and all that, you'll get that on the Telegram groups. Okay, ये है इस these couple of weeks का, and this is till the 16th. Can you guys hear me and see me clearly? आवाज साफ आ रही है? I know I always forget to ask that. Let me just go ahead and check the chat. Just give me a second. I'm just figuring out a couple of things on this thingy here. Animations, transitions, morph, and 0.7. Okay, yeah. Just trying to make the presentation thoda sa fluid आपके लिए. What's up, Priyanshu Rek? Hello. Thumbnail is epic. All right. Shlok, Sachin, good to see you. Surya Narayan. Surya Narayan. I'm a good friend with that name. You wanted thermo ka session and here it is. Yeah, आपका हुक्म सर आंखों पर. Okay, so you're able to hear me and see me clearly, I suppose. So let's get started. Let's get started. Have you guys solved some questions on thermo? पहला सवाल, everything's clear and audible? Okay, thanks, right? Thanks, right? First सवाल, पहला सवाल. Good evening, Tapan. How are you doing? The pressure volume work for an ideal gas is question number 8 from Exemplar. Can be calculated by using the expression W equals minus integral V1 to V Px into dV, Vi to Vf, I think it should be. All right. The work can also be calculated from the PV plot by using the area under the curve within the specified limits. For an ideal gas that's compressed A reversibly or B irreversibly, choose the correct option. And पहला ही सवाल बहुत ही fascinating है, बहुत ही fascinating है. Whether you do reversible or irreversible, इससे क्या फर्क पड़ता है? Well, work, as you know, is a path function. So depending on the path taken, उसकी value बदल जाएगी. These are paths. Reversible and irreversible are two different paths. ठीक है? I know बहुत लोग बोलते हैं ना कि path function और state function में क्या फर्क है? They teach you distance versus displacement. While it is good to get an initial understanding, displacement versus distance, ये example इतना अच्छा नहीं है. ठीक है, बिकॉज डिस्टेंस डिस्प्लेसमेंट तो बहुत अच्छी बात है, बट इससे आप लोग को लगता है कि पाथ मतलब कि कोई चल के जा रहा है. दैट्स नॉट हैपेंस एट ऑल. वर्क में ये पाथ्स हैं, रिवर्सिबल इरिवर्सिबल आर पाथ्स. P इक्वल टू 0 दैट्स अ पाथ, V इक्वल टू 0 दैट्स अ पाथ, Q इक्वल टू 0 वो भी पाथ है. ये सब जो हम रिस्ट्रेंट्स डालते हैं सिस्टम पे, दे आर ऑल पाथ्स. वेयर इज दिस यूजफुल? I have told you this hundreds of times before. Delta S is Q reversible by T. मतलब जो भी पाथ हो, डेल्टा एस सिस्टम विल ऑलवेज बी Q reversible by T. ठीक है, इसलिए वो वहां पे काम करता है. एनीवे, ऑल राइट Ronak, sure bro, we'll try and do whatever is possible, Ronak, but if you're looking for proper theory, yeah, I'm talking English, Oxbridge, my friend. Hare Krishna, Aditya, how are you doing? Okay, C, Priyanshu, Rek, Shlok and ASB Gaming are all saying C. Reversible is greater than irreversible, say all of you. Okay. Does everybody else agree with this? What do the rest of you think? How did you guys arrive at reversible greater than irreversible? This is how I look at it. Okay. Now हम लोग करते हैं, let's take something either expansion or compression, it doesn't matter. थोड़ा सा अलग हुआ दोनों का. Let's take compression. Compression मतलब कि initial pressure is low, final pressure is high. Okay. Compression क्यों होगा? Think about it like this. Now I've got something to compress. If I increase the pressure and I keep it constant, वैम, वन स्टेप। बाहर का प्रेशर ज्यादा है, अंदर का प्रेशर कम है, सो दैट एक्सटर्नल प्रेशर इज गोइंग टू डिसाइड द वर्क। ओके, सो इफ आई गो फ्रॉम वी आई टू वी एफ, एंड यहाँ पे पी आई टू पी एफ जा रहा है, ओके, वन स्टेप प्रोसेस is going to have this work. Ooh, lot of work. Compression. Right? Or what is it? Is that, does it make sense? Area maximum reversible. Yes, graph, largest area reversible, some compression, blah, blah, blah. You do graph, irreversible final point respect में straight line बनाते हैं. And since compression है, area less होगा, where reversible पूरा graph बनेगा. Rec, I love it. Rec has done something beautiful. Something beautiful. But here's the thing, right? अभी आंसर तो बी लिखा है इसमें, अब क्या करें, सब लोग सी बोल रहे थे, क्या करें? अकॉर्डिंग टू दिस व्हाट आई जस्ट डिड, राइट, कंप्रेशन वर्क में पीआई इज ग्रेटर देन पीएफ अगर कंप्रेशन हुआ तो, राइट, ये एक स्टेप का हो गया। अगर दो स्टेप में करें तो क्या होगा? दो स्टेप में ये होगा, दिस एंड दिस विल बी एरिया अंडर कर्व। तीन स्टेप करें तो क्या होगा? तीन स्टेप में एक हो जाएगा यहां पे समवेयर लाइक दिस, दो होगा यहां पे, तीसरा होगा यहां पे। तीन स्टेप में ये हो रहा है, ठीक है। सो यू सी वर्क काइंड ऑफ रिड्यूसेस। अगर कंप्रेशन वर्क है तो कम होता जाता है, ओके, रिड्यूसेस, कूल। अब क्या हो गया? व्हाट्स हैपनिंग? साइन, ओके, ऑलराइट, वाओ, ओके। सो व्हाट इज द साइन ऑफ वर्क? वर्क का साइन इज माइनस पी डीवी। सो कंप्रेशन मतलब पॉजिटिव होगा, राइट, ओके। कंप्रेशन वर्क में इट इज वेरी इजी टू सी हाउ वर्क रिवर्सिबल इज लेस देन वर्क इरिवर्सिबल। अगर कंप्रेशन में इट डजंट मैटर इन एरिया, प्रियांशु सेज, ओके, ऑलराइट, ठीक है, लेट्स सी। व्हेन यू टेक कंप्रेशन का एग्जांपल, इट इज वेरी एविडेंट कि वर्क डन रिवर्सिबल इज लेस देन वर्क डन इरिवर्सिबल। डू यू सी दैट? जो मैंने कंप्रेशन का एग्जांपल लिया, देखो येलो वाला एक स्टेप का हुआ, हरा वाला दो स्टेप का हुआ, ब्लू वाला तीन स्टेप का हुआ। आई विल राइट दैट वन मोर टाइम। दिस इज वन स्टेप, दिस इज, कहां गया ये, दिस इज टू स्टेप्स, एंड दिस इज थ्री स्टेप, ठीक है, या व्हाट डू यू गाइस थिंक? प्रथम, हाय, श्लोक, साइंस, साइन की बात करें, विल टॉक अबाउट द साइन, विल टॉक अबाउट द साइन, बात करेंगे। ड्रॉ करने में इरिवर्सिबल का ही होगा, राइट, ओके। सी व्हेन यू टेक द साइन थिंग्स बिकम अ लिटिल कंफ्यूजिंग, आई एग्री, इसलिए मैंने सिंपल वाला लिया। अभी एक्सपेंशन में भी आई कैन प्रूव द सेम थिंग टू यू। आई ट्राई माय बेस्ट, मैं कोशिश करूंगा। देखते हैं, विल सी। साइन के साथ करते हैं, बिना साइन के साथ करने में तो आसानी से समझ में आ रहा है, राइट, विदाउट द साइन, विद कंप्रेशन मतलब विदाउट साइन, ठीक है। विद साइन विल सी, ओके, लेट्स सी। आई विल टेक 5 मिनट्स। मुझे लगा था कि पहले वाले में थोड़ा डाउट होगा, इसलिए आई केम प्रिपेयर्ड विद सम थ्योरी। डू यू सी दीज टू थिंग्स? इसमें कुछ अलग हो रहा है। गुड जॉब प्रथम, आई एम प्राउड ऑफ यू। लिसन, थोड़ा ध्यान से सुनो, एडवांस की तैयारी कर रहे हो ना, ध्यान से सुनो, जरूरी है ये सब एडवांस में। कंप्रेशन और एक्सपेंशन में कुछ अलग लिखा है, ये समझ में आ रहा है क्या हो रहा है? व्हाट इज हैपनिंग? यहां पीएफ लिखा है, यहां पीएफ लिखा है। इन एक्चुअली एक्सटर्नल प्रेशर इज द फाइनल प्रेशर। व्हेन यू हैव अ इरिवर्सिबल प्रोसेस, जो एक्सटर्नल प्रेशर होगा वही होगा फाइनल प्रेशर। ये समझ में आ रहा है? बहुत जरूरी, बहुत बेसिक पर बहुत जरूरी चीज है। इसीलिए देखो कंप्रेशन एक्सपेंशन में कितना फर्क है वर्क डन का। कंप्रेशन में बहुत ज्यादा एफर्ट लग रहा है, एक्सपेंशन में बहुत कम, जो है बहुत आसानी से एक्सपेंशन हो रहा है। जैसे आप इसको दो स्टेप में करोगे, देखो बोथ दीज स्टार्ट टू कन्वर्ज। तीन स्टेप में करोगे और कन्वर्ज होगा, ठीक है। लुक एट दैट, दे ऑलमोस्ट द सेम। साइन मैटर्स नहीं प्रथम, साइन डज नॉट मैटर। आई विल गेट टू दैट पार्ट। साइन वाले पार्ट में आता हूं, आई विल कम टू द साइन वाला पार्ट। You keep increasing the steps to infinite steps, it becomes this. Okay. So, okay. Now, look at this. ये मॉड्यूलस अगर लो, तब reversible expansion will have maximum work. When you take मॉड्यूलस, अगर मॉड्यूलस निकले तो क्या होगा? This is more negative. This is less negative. अब इस केस में भी, अब देखो साइन के साथ भी ले लो, इस केस में भी वर्क इरिवर्सिबल इज ग्रेटर देन वर्क रिवर्सिबल. यू सी दैट इवन इफ यू टेक विथ साइन, इवन विथ साइन. दो अलग अलग चीजें मैं साथ में बात कर रहा हूं. मैं पहले इस क्वेश्चन को एड्रेस करना चाहता हूं. ओके, इन दिस क्वेश्चन ये मैटर करता है. टू स्टेप वाला समझ में आया, प्रथम एक्सप्लेन करूंगा, डोंट वरी अबाउट दैट. बट यू सी साइन डजंट मैटर, ये मैं प्रूव करना चाहता था. प्रथम टू स्टेप वाला आई विल एक्सप्लेन, डोंट वरी, आई विल एक्सप्लेन इन अ सेकंड. बट डू यू अंडरस्टैंड दिस, है ना? वन स्टेप का समझ में आ गया, वन स्टेप इज फाइन. अगर वन स्टेप समझ में, टू स्टेप भी आ जाएगा. देखो टू स्टेप में किसका नहीं समझ में आया? दिस इज एक्सपेंशन, राइट? दिस इज कंप्रेशन. कंप्रेशन में क्या हो रहा है? कंप्रेशन में आई विल गो बैक टू द टू स्टेप वाली चीज. ओके, टू स्टेप में क्या हो रहा है? गो बैक टू दिस. टू स्टेप्स में फर्स्ट स्टेप मैंने इसको जो है, दिस इज द फर्स्ट स्टेप, इंटरमीडिएट प्रेशर में डाला. इंटरमीडिएट प्रेशर, दिस इज द एक्सटर्नल प्रेशर. ठीक है, इसीलिए आई हैव टेकन दिस एरिया ऑफ द ग्राफ एंड नॉट दिस, बिकॉज दिस विल बी देयर एक्सपेंशन में. यू सी, एक्सपेंशन में इंटरमीडिएट प्रेशर है. वट एवर द फाइनल प्रेशर इज, दैट इज व्हाट आई हैव टू कंसिडर. ओके, expansion में final pressure is going to be lower than initial pressure. Okay, that is the key over here. अगर ये आपको डिटेल में पढ़ना है, मैंने बहुत पढ़ा है, आपको जो है you'll have to watch the theory sessions. ठीक है, अगर at this point ये चीज थोड़ी फॉरेन लग रही है, फॉरेन मतलब कि एलियन, नॉट की वेरी क्विक, अगर बहुत जल्दी या फॉरेन लग रही है, प्लीज चेक आउट द थ्योरी सेशंस हियर. आई एम गोइंग टू हैव टू गो अहेड ऑफ दिस. प्रियांशु डाउट है साइन में. साइन में कैसे डाउट है प्रियांशु? यार प्लस माइनस का चीजें लिख लो, राइट इट डाउन, डोंट ट्राई एंड थिंक इन योर हेड. लिखो ना. देखो साइन में क्या दिक्कत है? दिस इज नेगेटिव, है ना? व्हाट इज मोर नेगेटिव? दिस इज मोर नेगेटिव, दिस इज लेस नेगेटिव, सो दिस इज लार्जर. खत्म, आंसर इज स्टिल गोइंग टू बी द सेम. ठीक है, वन स्टेप, मल्टी स्टेप, एटसेट्रा एटसेट्रा. आई विल गो बैक टू दैट ऑप्शन. ऑप्शन में तो यही आंसर है, करेक्ट है ना? देखो, इट डजंट मैटर वेदर यू डू दिस, दिस इज रिवर्सिबल. ठीक है, ये है तुम्हारा कंप्रेशन वर्क. कंप्रेशन में क्लियर है ज्यादा है. ये है तुम्हारा एक्सपेंशन. ठीक है, एक्सपेंशन में कम लगता है, बट दिस इज लेस नेगेटिव, नो, एंड दिस इज मोर नेगेटिव, सो इन दैट केस आल्सो इट इज लार्जर. खत्म. ठीक है, ये समझाने के लिए आई टुक 10 मिनट्स, बिकॉज you need to understand this to be able to do things properly. ठीक है, पहला सवाल, we spent a lot of time on this because it's necessary, because सब लोगों ने गलत आंसर दिया. It's okay अगर गलत आंसर, कोई प्रॉब्लम नहीं है. Now I hope you understand कि क्या है सही यहाँ पे. ठीक है, whether साइन के साथ हो, साइन के अलावा वो, वर्क irreversible is greater than work reversible. खत्म. Consider reactions given below. On the basis of these reactions, find out the algebraic relations given in options 1 to 4. ये तो ज्यादा सिंपल हो गया. ठीक है, बताओ अब इसमें क्या होगा? व्हाट अबाउट दिस? नमन, प्रणाम, हाउ यू डूइंग? प्रथम, प्रियांशु, रेक, श्लोक, कहां गए आप लोग? एएसबी समझ में आया? श्लोक सेड इज गुड. रेक ने फिगर्ड आउट हाउ द ग्राफ में कुछ गड़बड़ हो गया, दैट्स ओके. ऑक्सब्रिज, आई एम टॉकिंग इंग्लिश. ऑक्सब्रिज, वेयर डू यू गो ब्रो? ASB gaming is Aditya. Okay, cool. Enthalpy of formation. Okay, all right. So what is this? Which one is it? This is delta HF. This is not delta HF. So what? Delta HF, so what? That's good. अच्छा है, समझ में आ गया आदित्य. Good. Got it, Siddhi? Good. Hey, good to see you, Siddhi. Okay, Pratham. So what? Okay, enthalpy of formation. Good job. अब क्या करें? थोड़ा बताइए. थोड़ा सोचिए, ना, ध्यान से सोचिएगा. आई एम नॉट स्केयरिंग यू एनीथिंग, आई एम जस्ट सेइंग ध्यान से सोचो, इसको जल्दी में मत करो. एक क्वेश्चन ऑलरेडी जल्दी में गड़बड़ हो गया, व्हिच इज ओके, नॉट अ प्रॉब्लम. वी आर हियर टू हेल्प यू आउट. बट कैसे, क्या, क्यों, व्हाई, व्हाट, व्हेन, हाउ? व्हेन नहीं होगा, टाइम की कोई केमिस्ट्री में, आई मीन थर्मोडायनेमिक्स में टाइम का कांसेप्ट नहीं होता, दैट्स इन किनेटिक्स. Thermo mainly about how. I'm going to give you a hint. Chat, pardon, I'll address the chat. What's the hint? In the first one, bonds being formed only. In second one, formed and broken. बट इसमें फॉर्म्स हो रहे हैं. क्या करें? C is already a gas in A. Sir, solid say gas enthalpy of sublimation atomized H का difference है. Shlok, lovely, I like this. Same, I think D सब लोग बोल रहे हैं D. Okay, cool. C is already in gas, one state, always late. Makrand, it's okay, bro. बताओ. Carbon, okay. Divya, all right. C, D, okay, all right. What do you think? After this hint, क्या लगता है आपको? Atharv, good evening. Atharv, is this the same Atharv from Discord? Atharv, the hero. Athu, is that you? That rhymes. Okay. X plus H sublimation plus of C plus delta H atomization. That will give me, yes. So, this is going to be very, very big. X is going to be very negative, whereas Y is going to be less negative because I have to add some things to it. Is that correct? Yes, सही लग रहा है. X is very negative, right? Because इसमें only bonds are being formed. Y is going to be less negative because I have to also, as Pratham, as Shlok and everybody else said, you have to provide energy to break the graphite solid bonds to make it an atom, gaseous atom, and you have to break H, atomize that, right? 2H2 has to become H, right? So, with that in mind, what happens now? देखो, delta H is given in X kilojoule per mole. Now, the problem is Y is greater than X is what you're saying. Okay, Priyanshu. Okay. Correct hai? Okay. All right. Now, this is when things get interesting. This is what NCERT says. NCERT says X is greater than Y. Why is NCERT saying X greater than Y? Oh, Aditya also saying the same thing. Okay. I know this one's a little annoying, right? Because just in the previous one, I proved to you with sign what happens. Now, if you take the sign of stuff, if you take just the sign, अगर आप sign लो, right? So negative wise, X is smaller, i.e. less negative, sorry, more negative. But if you look at the point of energy, right? Energy ज़्यादा निकल रही है in X and Y may come. That's the logic they're going with in NCERT Exemplar, hence X greater than Y. Okay? Yeah, Shlok, thank you for that. If I take mod, then X is greater than Y. Absolutely right. Yeah. Shlok, Sachin, Siddhi, negative. Yes, absolutely. Now, this is not a very well-framed question. I'll be honest with you, right? Because you go with this, I think they should ask mod. I think they should go with mod. In the option, they should put the mod value. They should do that. Without that, it's not a fair question. Yes, I feel so too. Let's go to the next one. अगले में जाते हैं. Shall we do this? I think it's rather simple. Let's go to another one. This is very easy. Let's go to something that's a little bit more fun. Can help you? Oh, this one's nice. Yeah. No. This is also straightforward. Let's go to the next one. If we have time, we'll come back to all these easy ones. We have some interesting ones to come that are coming up. Okay. A sample of 1 mole of monatomic ideal gas is taken through a cyclic process of expansion and compression as shown in this figure. What will be the value of delta H for the cycle as a whole? This is a 30-second question, but my timer doesn't seem to work anymore, so I'm just going to start a timer. Where is my phone? Oh, it's right here. Let's do the timer. I think we can do this in 30 seconds. Stopwatch, timer. Seconds, 30. Wow, this is so complicated. Okay, I'm starting the time. What do you think the work is going to be? Yeah, Siddhi, thank you. While I was starting the timer, Siddhi's got the answer right. Yeah, it's 0, cyclic process. It's cyclic, guys. Delta H is a state function, guys. So state function mein initial and final state is the same. So delta H will be 0. Delta U will be 0. Work, however, is non-zero. Q hence is non-zero because delta U is Q plus W. We're not talking about that though. We're talking about, oh, I explained the answer. In 30 seconds, we explained the answer as well. That's lovely. Thank you, Siddhi, for that quick answer. Absolutely right. Shlok, Aditya, Priyanshu, Rek. Yes, absolutely. Pratham, Divya, bilkul sahi. Hi, everybody. Hi, Harshit. How you doing? Welcome, welcome, welcome. अगला सवाल करते हैं. क्या किया जाए? We have some fun questions coming up. We have a lot of time. अभी सिर्फ 20 मिनट हुआ है क्या? We started at 6:30, right? Oh, then we have a lot of time, bro. We started at 6:30. Okay, we'll go through the motions. Let's do the easy ones. Let's do the easy ones. The standard molar entropy. Oh, this is a nice question. The standard molar entropy of H2O is 70 joule per Kelvin per mole. What will be the standard molar entropy of H2OS? H2O solid. This is solid. यहाँ पे है L यानी कि liquid. So the question being asked is it more or less than this value? Now, modulus, okay? Modulus. More or less than this value. How do you tell? There's nothing else that's given to you. No other numbers, nothing. Just one thing. Standard molar entropy. Pani, liquid H2O. Oh, speaking of pani, I don't think I got my water. I'll go and fetch my water quickly. Should be less unless some exception. Slok is like treading really carefully unless some exception. Should be less. Yeah, absolutely right. H2OS should be less than H2O liquid. Why? Because to convert a liquid to solid, some entropy is lost. Entropy kam ho jati hai. It's as simple as that. Good job everybody. Good job. Yes. Bilkul sahi. Agla sawal karte hain. Okay, this one's easy. This one's pretty easy. Although heat is a path function, yes, Abhinav, Shlok, Priyanshu, Siddhi, Harsh, Patel. Harsh, is it same Harsh from Discord? Harshit, Pratham, Divya, Siddhi, Rek, and Shlok, who started this off. All of you absolutely right. Although heat is a path function, heat absorbed by a system under certain specific conditions is independent of the path. What are these conditions? कौन से conditions है जहां पे work, जहां पे heat becomes path function? Path functions. Yes, Aditya, bilkul right. Absolutely right. What do you think about this one? क्या करें इसका? I think it's doable, right? Not very complicated. I think very doable. I'm gonna go and fetch some water right after this. Is there a numerical coming up? I think there's a numerical. Seek and you shall find. अगला सवाल एक छोटा सा numerical है. करते हैं. What do you think? Okay, Siddhi, thank you. Siddhi is giving me one. All right, Siddhi is giving me both the things. Exactly. Now, Q is a heat, is a path function. Which means you whether have reversible or irreversible or something else, its value will be different. If I, have some constraints or conditions, it'll give me different values. And because of this is something very interesting that happens, right? Check this out. Now, if I fix the pressure, and I'm heating yahan se, yeah, this is all thermally insulated. Matlab ki nothing goes out of here. Just heat can come in from this wall. Okay. So what happens is that this is what? Not constant pressure. Sorry, this is constant volume, right? The volume is fixed. So all the heat directly increases the temperature, and assume that there's a gas here, right? For sake of simplicity for right now. All the heat that goes in just increases the temperature. So you get this beautiful expression mc times delta T, and we call this CV delta T. This happens to be delta E. This is the first state function, okay? So heat is a path function, becomes a state function when I make this volume constant. This is the first one, okay? What about the other guy? Yeah, this was not here. I fixed it. मैंने इसको fix कर दिया, ऊपर भी fix कर दिया. There's no piston here. This is this, okay? What if I let it move around? I do the same thing, but now I have a piston, which means it's flexible and it can kind of, move upper niche, up and down, round and round. I do the same thing. This is insulated, so heat only goes in this way. So heat gets added. But now, because I've done this, this guy moves up by a little bit, by let's say D, right? Now, force times D gives me the work. This is doing work. Literally, this is the best way to visualize work. The gas is doing work against the external pressure, which is what? External pressure kya hai? It is atmospheric pressure plus this mg by A, whatever this area is. मैंने कुछ mass ऊपर डाले. So this is a little bit of physics, a little bit of physics. This is external pressure. Assume it to be irreversible, etc. F into D, actually, technically, since physics की बात करें, तो F dot B. And because it's working in a, against the external pressure, you have a negative sign over here, etc. हम लोग sign की भी बात नहीं करेंगे. I'm not going to do the derivation. But basically, here I have constant pressure, and here the heat is doing two things. One, it's increasing, just like last time. It is increasing the heat. Yeah, it's increasing temperature, and it is doing some work. But this is known as enthalpy. थोड़ा सा देखो, पूरा first law खत्म हो गया. Yeah, that's it. We are done with thermodynamics का first वाला part. Done. Good evening, Nidhi. How are you doing? Q at constant volume U at constant pressure H, both are state functions. Del H is equal to del U plus PdV. All right. Nice. Constant P and V. Shlok. Yeah, it's बहुत आसान question. Exactly. बहुत आसान question. But I just wanted to go over. Ria, good evening. Wanted to explain why is it that it's a state function. हमने पूरा thermo revise कर दिया. First law of thermo हो गया. Okay. Recap of this. You heat with a fixed volume, then all the heat goes to increase temperature. Now, some heat goes to increase temperature, some heat goes to expand the gas. That's it. So, that's enthalpy. Okay. All right. Let's go to the next question. The net enthalpy, speaking of enthalpy, net enthalpy change of a reaction is the amount of energy required to break all the bonds in a reactant molecules minus the amount of energy required to form bonds and blah, 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 blah. A lot of kahani, ram kahani. What will be the enthalpy change for this reaction? You have been given bond energy. What is bond energy? Bond energy hota kya hai? Quick hint deke, I'll go get some water and come. Bond energy matlab energy input required to break the bonds. Matlab you start with this on the LHS. Now, what is LHS, RHS? I'll explain to you the moment I get back. Common man? Oh, come on, man. That's so easy. It is easy. Exactly. NCERT is easy. JEE Main is easy. All you've got to do is solve NCERT. And ये तो exemplar भी है. कर लो, आराम से हो जाएगा JEE. Try this question out. I'll be right back. Yeah, please try this question out. ये भी बहुत जल्दी हो जाना चाहिए. Let's go. Okay, this is also one of those easy questions. जैसे आपने सब बोला. -109. Let's see. Let us see. Yeah, absolutely right. How did you guys get -109? Oh, Siddhi को लग रहा है positive. Negative. यही तो चक्कर है पूरा. And this thermochemistry सवाल JEE बार-बार पूछता रहता है. Negative, positive कैसे figure out करोगे? देखो, this is my logic. You need to know what the definition is. Definition मतलब formula नहीं. Definition. Bond energy की definition क्या है? I have X2. I provide energy. It becomes 2x. Right? Which means कि जिस चीज की bond energy दी हुई है, that is on the LHS of the equation. Okay, which means कि अगर LHS में है चीजें, like देखो ये तीनों की दी हुई है ना, HBr, तो उन तीनों को LHS में करे तो पॉजिटिव हो जाएगा, if on RHS then वो नेगेटिव हो जाएगा. That's all bro. So you need to know the definition. So ये दोनों होंगे पॉजिटिव, ये हो जाएगा नेगेटिव into 2 because of stoichiometry की वजह से. All right. So what are we doing? We are adding 435, we are adding 192, and we are subtracting 2 into 368. That's a big number. I hate addition and subtraction. I think addition is still kind of okay. Subtraction, however, that's my bane. Like that's like the worst thing ever. Subtraction is hard, bro. Anyway, when you subtract this, you get negative 109. Because I know the answer. I would be really bad at subtracting it myself. It's okay. All right. No problem, Harshit. सिद्धि जा, ये मैं बोलना चाहता हूँ, ये प्रोडक्ट माइनस रिएक्टेंट, रिएक्टेंट माइनस प्रोडक्ट, ये सब मोह माया है, इसको छोड़ दो. नेवर मक दैट. दैट्स लाइक द वर्स्ट थिंग टू डू. आई डोंट नो व्हाई एवरीबॉडी डज दैट. इट्स लाइक इट्स नॉट इजी टू डू दैट. प्रोडक्ट्स माइनस रिएक्टेंट, कौन याद रखेगा ये सब चीजें? डेफिनेशन से करो. डेफिनेशन क्या है देखो. लेट्स रिवाइज अ कपल ऑफ अदर डेफिनेशंस. लाइक फॉर एग्जांपल, फॉर कंबस्शन, कंबस्शन में क्या होता है? यू हैव x plus O2 gives XO whatever 2 random. ठीक है. Again LHS पे है what you starting with. What about delta HF? You have blah 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 giving X. ये है RHS पे. अरे माफ करना, ये है RHS पे, है ना? This is what you need to remember. और क्या है? Give me anything. Throw anything at me. I'll tell you how to handle it. Atomization. Atomization is the same as bond energy. Atomization या फिर bond energy. Yeah, इन दोनों में again LHS. Anything else comes to mind? So what is LHS RHS? By definition it's on LHS RHS. मतलब कि actually if it matches जो LHS में है आपके पास और आप the value given also LHS, make it positive. If the equation has it on the RHS, negative कर लो ना. That's all यार. This is a just arithmetic. कुछ fancy नहीं है. ठीक है? No multiplication. I don't like arithmetic at all. Slow multiplication फिर भी ठीक है. Subtraction is the worst. Multiplication फिर भी ठीक है. Division is fun because you can cancel stuff out with division. It's awesome. Like division is the best. Division I think is the best. It's better than addition. It's better than subtraction. It's better than multiplication because you can just cancel stuff out. Next question. We have time. We have a lot of time. 1 mole of a monoatomic ideal gas is expanded from state 1 to state 2 as shown in this figure. Calculate the work done for the expansion of gas from state 1 to state 2. आई ये ज्यादा सिंपल नहीं हो गया? चलो कर लो यार, कर लो कर लो कर लो. आई थिंक वॉल्यूम फाइनल नहीं दिया है, दैट्स द ओनली थिंग हियर, बट यू कैन गेट द फाइनल वॉल्यूम आल्सो, राइट? इफ यू हैव बीन गिवन इनिशियल प्रेशर, इनिशियल प्रेशर्स ऑफ बोथ V2 एंड V1 एंड V2 दोनों हुआ है, तो कर सकते हो ना. हाउ P1 V1 इक्वल टू P2 V2. क्यों 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 क्यों? Because this is an isothermal process. Again, isothermal process है. Then, yeah, bro. That's all you gotta do. I don't see what this is. So this is going to be basically what, 22.7 by 2. I mean, do you even need this? I don't think you need this, right? You can also just use another expression of this. The deal is ki it's integral minus of P dV. What is P? PV is equal to nRT by V. Okay. So then that becomes integral negative N RT V by VV. Wow, wow, wow. Badhiya math. dV by V. This becomes, why did I write approximately? This becomes minus nRT ln V2 by V1. V2 by V1 is the same as P1 by V2. P1 by P2. कुछ नहीं लगता इसको करने में. This is basic, like so basic, so basic. Yes, Harshit, it will. I'm doing exemplar questions, bro. मैंने कब बोला एडवांस के सवाल कर रहा हूँ? These are all exemplar questions. But the theory you need to know is the same for advanced. If you're here for advanced things, last 15 minutes, that's when we do advanced questions. Yeah. But Harshit, where's the answer? आसान है तो अच्छी बात है, but answer तो बताओ. Isothermal, Siddhi, yes. How do you know it's isothermal? Siddhi is asking right questions. It's given here that temperature is fixed. State 1 to state 2 at 298 Kelvin. अगर टेम्परेचर बदल रहा होता तो यहाँ पे लिखा जा रहा था, ठीक है? It would have been said here very, very clearly. What's the answer to this, guys? बताइए बताइए बताइए. N is 1, R is 8.314. Yeah, thank you, Aditya. Exactly. Thank you so much. It is exactly minus 1711, not minus. It's actually uh, minus 1717 point something, right? Not 1717. Yes, minus, exactly. Priyanshu minus rec minus श्लोक प्रेशर का यूनिट बार, एक बार पहले वाले में लिखा नहीं था क्या? सॉरी, माफ करना, मुझे लगा था लिखा था बार, बट या श्लोक बीइंग रियली केयरफुल. देखो बिकॉज वॉल्यूम यहाँ पे 1 पे ये 22.7 दिया है ना, तो दैट्स व्हाई आई न्यू इट वाज बार. ठीक है, बिकॉज वॉल्यूम एट 1, देख श्लोक, हाउ डू आई नो द यूनिट ऑफ दिस थिंग? अगर ये वॉल्यूम होता 22.4 देन इट वुड बी एटमॉस्फेयर. ठीक है श्लोक, दैट्स द लॉजिक. दिया नहीं है तो क्या, यू कैन स्टिल फिगर इट आउट. दैट्स ओके प्रियांशु, दैट्स ऑल राइट. Hey Rishabh, Hare Krishna, what's up? That's all right, I'll use a calculator, not a problem at all. Let's not do this. ये बहुत कर चुके हैं. We've already done enough of expansion in this thing. Let's go on to interesting ideas. Let's go on to more interesting ideas. How about this one right here? Match these following parameters with descriptions for spontaneity. And let's go to the second part of thermo. इससे सवाल कम आते हैं JEE main में, but anyway, these are very easy things if they come at all. Yeah, Priyanshu, that also works. Rex ने ज़्यादा approximate कर दिया. That's okay, Rex, that's okay. As long as you're getting a negative sign, that's fine. Yeah. What do you think about this? Adiabatic, please. Is that like a new slang that I don't know? What about adiabatic? इसको करते हैं. That's okay, Rishabh, not a problem at all. As long as you find them useful, कभी भी देख लो. How do you match this, guys? Help me with this one. डेल्टा H, डेल्टा S और डेल्टा G की वैल्यूज यहाँ पे दी हुई हैं एंड डिस्क्रिप्शन कुछ दिया हुआ है. हाउ डू यू मैच देम बोथ? हेल्प मी आउट प्लीज. Help me out here. So if what do I do here? I get delta G equal to delta H minus T delta S. Let's put knots everywhere. Okay. Now if this guy is positive, okay, this is negative, which means that T delta S is going to be positive and this is positive, which means, yeah, this is going to be spontaneous at all temperatures, non-spontaneous at all temperatures. That's what this one goes with, I think. What do you think? Minus minus matlab ki, okay, this is negative and this is positive. So at high temperatures it's going to be non-spontaneous, right? Yeah. Is it non-spontaneous or is it going to be spontaneous? Yeah, this is also going to be non-spontaneous, right? क्योंकि ये भाई साहब negative है, which is nice, but then if the temperature is too high, this you know, T delta S is going to be greater than delta H, hence it's going to make it spontaneous, non-spontaneous at high temperatures. Very easy stuff, but इस पे आते हैं सवाल, because JEE main is easy, bro, right? So let me just put it straight, be very categorical about it. When I say easy, if you know the theory, it's easy. If you don't know theory, it's hard. It's vast. मैं ये नहीं बोल रहा हूँ कि कम है, syllabus बहुत ज़्यादा है. I agree, right? I'm not against that at all. But at least from the Jan attempt, they've given you questions directly from the NCERT. So that's why I'm doing that right now. Exemplar इसलिए हम लोग आपके साथ कर रहे हैं. Last वाला तो obvious है. Yeah, delta G naught is negative. This guy is positive. मतलब कि T delta S, negative T also is always going to be negative. Negative. So it's always going to be spontaneous at all temperatures. Easy. Yeah, exactly. Thank you for the answers. Riya, Siddhi, first is C. Thank you. Priyanshu, Rek, Aditya ने retract कर दिया answer. Priyanshu, all right. Shlok, yes. Abhinav, all right. No, Priyanshu, I'm not saying that at all. I'm saying you gotta set your goals realistically. All right. I see students studying a lot of things that are not necessary for JEE, and a big reason behind that, and I'm gonna be straight about this, is the way things have been in the last 20 years, right? But वो JEE Advanced के लिए पढ़ाते हैं. See, most coaching institutions teach for JEE Advanced. But if your focus is JEE Main, you got to study for JEE Main, right? If you're going to go and watch videos or content for JEE Advanced, it's not going to help you for JEE Main. JEE Main content will help you for JEE Advanced. JEE Advanced content is not going to help you for JEE Main. ठीक है? Because कोई random चीज, see, JEE Main has now become a very high scoring exam. Okay, there are 8 people who got 300 score, 100 percentile in the first shift. It's a very high scoring exam. It didn't used to be like this, but it is now. This is the reality. Accept it, move on, and that's what my suggestion is to you. Here, next question. Couple of assertion reason questions. Spontaneous process is irreversible, blah, blah, and may be reversed by some external agency. decrease in enthalpy is a contributory factor for spontaneity. What do you think about this? What do you think about this? Slok, I agree, but it's okay. It's going the SAT way. It's going the SAT way. Yeah. Easy exams are not fun. Easy exams में बहुत गंदा competition होता है. Easy मतलब कि high scoring. I'm not going to call them easy and hard. Let's call them high scoring exams. Easy is subjective. High scoring is not subjective. तो high scoring it is a fact. Easy मतलब मुझे easy लग रहा है किसी और को easy ना लगे, right? But high scoring is a fact. So high scoring exams are hard. Look at NEET, look at SAT, look at GMAT. All high scoring exams. All right. Anyway, how about this one? What do you think in this? Simple सा question है. करते हैं जल्दी से. C. A is true but R is false. Divya, C. Okay. Shlok is also saying C. Okay. Decrease enthalpy contribute factor. क्यों? Decrease enthalpy तो होता है ना. Delta G is delta H minus T delta S. तो अगर decrease हुई enthalpy, that's good. Enthalpy का decrease होना. What are you saying? Why are you saying R is false? मैं समझ नहीं पाया. मुझे तो दोनों सही लग रहे हैं. Spontaneous process is an irreversible process and may be reversed by some external agency. Okay. Reversible, irreversible, spontaneity. This is interesting. You think B. Okay. All right, Aditya. यार C तो नहीं लग रहा है. R तो सही है ना. R is definitely सही. R is correct, I feel. Right? Because this is true. I feel this is true because I've just shown you by the equation. The first one, spontaneous process, irreversible process, and may be reversed by some external agency. Okay, spontaneous process, irreversible process. Sure, think about it like this. अगर पानी ऊपर से कहीं से गिर रहा है, और hold on. Think about this. Think about a fridge. Right? The fridge is the external agency. Normally क्या होता है? Hot things get cold. Right? Fridge उल्टा करता है. Hot things get cold. This is irreversible, bro. But I reverse that process by motor, Carnot cycle, etc. You know, जो भी है, वो सब चीजें. I think I'm messing up the physics part of it. But yeah, whatever. This is second law of thermodynamics, right? कि you cannot have anything without that loses. I'm not going to try. You know this. You read entropy, okay, Divya. All right. प्रियांशु इसलिए D होगा. I feel it should be B. दोनों सही है. Yeah, exactly. दोनों सही है. Why is A correct? I'm explaining, Priyanshu. Why is A correct? Look at this. Here's an example. Whenever you feel कि कोई subject, कोई चीज सही है कि नहीं है, example लेके देख लो ना. Yeah, exactly. Thank you. Exactly. Decrease enthalpy उसी example में. Yeah. All right. Cool. Awesome. It will, Aditya, exactly. जब delta H कम होता है, it will lead to negative value unless more negative value than what it was before. So it is increasing spontaneity. ठीक है, चलो. With that, I feel like we have done a lot of interesting questions. We can do one more small question maybe, and then we'll go on. Now, let's go on to the fun question. No more small questions. Let's go on to the fun question directly. Okay, let's go. Fun question. From here on, we're going to do things that are JEE Advanced focus. Harshit Bhai Sahab, आप यहाँ पे हैं? आप बोल रहे थे you wanted JEE Advanced content. This is JEE Advanced content. How is it different from what you've done so far? It's not, to be honest. The question now is JEE Advanced focus. अभी तक whatever I was teaching you is relevant for JEE Main and for JEE Advanced and for NEET. जो अभी तक मैंने पढ़ा है. Right now, from now on, the last 15 minutes of this session, we are going to focus on questions that will help you think in a way that will help you for the JEE Advanced exam. Okay. Now, there are two perfectly insulated containers. One has an ice cube at 0 degrees Celsius and water at 0 degrees Celsius. The second one is ice cube at 0 degrees Celsius and salt water solution at 0 degrees Celsius. That's interesting. Namkeen pani, brine. Consider the process H2O solid becoming H2O liquid. What is the sign of delta S? Delta S surrounding and delta S universe in one. First part. Give me the answer of this. So whatever, plus, तीन चीजें होंगी ना, जो भी हो, give me answers. Once you are satisfied with that, go to the next one. What is the sign of all of these things? In two. ठीक है? Aditya, it may not always be the case. Aditya, I'm sorry I missed your comment. Why not correct explanation? It may not always be the case. It may not always be the case. It could also be entropy, right? Increasing entropy, like the example that I gave you of this No, actually, that example is not good. Just a gas expanding, like gas hai, you have gases and you have this sort of a barrier between two gases. You remove the barrier, entropy increases. Now there is no delta H यहाँ पे. There's only entropy increasing, which is leading to delta G. So it is not always the case. Hence, it is not the right explanation. ठीक है? What do you think about this? इस क्वेश्चन के बारे में क्या हुआ? कोई कुछ बोल नहीं रहा है, क्या हुआ? ज्यादा भारी हो गया पहला ही सवाल. Okay, thanks Siddhi. Siddhi is giving me some ideas. Siddhi is saying negative plus and plus. Siddhi, can you help me out with what was your reasoning behind this? Siddhi, इसके बारे में क्या था आपका reasoning? Let's talk about this process. This is at equilibrium at 0 degrees Celsius. No doubt whatsoever, right? पानी, pure water, equilibrium पे होगा 0 degree Celsius पे. I know anomalous expansion वो सब drama है, but I'm just talking about bro, ice converted water, कुछ नहीं हो रहा है. Okay, it is going to be at equilibrium at 0 degrees Celsius. That's the hint. That's the hint. Okay. Siddhi, why heat loss? It's at equilibrium. It's at equilibrium. श्लोक ने पकड़ लिया. श्लोक ने hint पकड़ लिया. The moment I said equilibrium, I think, you know, like a bulb kind of just flew over. Where's that bulb? There's the bulb. And goes, is that a good bulb? I don't know. How do I draw light? There you go, light. जैसे ही बोला equilibrium, that's what should happen, right? Yeah, yeah, exactly. Ria, you're right. Siddhi, do you understand why it's all going to be zero, right? Because equilibrium में, when stuff is at equilibrium, first step you should think. This is सोचने का तरीका, ठीक है? You may mug things different ways. मैं बोल रहा हूँ सोचने का तरीका क्या होती है? Equilibrium मतलब delta S universe is zero. मतलब universe का कुछ नहीं हो रहा है. Universe is zero मतलब कि delta S system equal to minus delta S surrounding. But delta S system also is zero. Delta S system is zero because Q is zero. Heat कहीं आ जा नहीं रही है. Equilibrium में मैक्रोस्कोपिकली कुछ नहीं बदलता है, माइक्रोस्कोपिकली चीजें होती रहती है, माइक्रोस्कोपिक कुछ नहीं होता है, ठीक है? So hence, if delta S system is zero, then surrounding also should be zero. So तीनों will be zero for the first one. Okay, let's look at the second one now. Any doubts in the first one? Please ask me. I have all the time in the world. Any doubts? Please ask me. Second one, my shlok says minus, plus, and zero. Okay. Exactly, shlok. It's insulated, perfectly insulated. तो heat तो नहीं होगी ना? How will heat exchange? Heat, let there be light. Yeah. Bible quotes. Okay. Yes, Riya. Thank you. Siddhi, insulated है ना? Insulated है तो क्यों कहीं जा नहीं रहा? Yeah. Second में minus plus zero. Okay. Says Shlok. Anybody else wants to guess? Second में Riya is saying 0 0 negative 0 0. Okay. Riya is saying negative 0 0 for second. Okay. Very interesting. Very interesting. कोई मुझे लॉजिक बता सकता है? Second में what is the starting point? What are you thinking first? Second में, let me give you a hint. There's a chapter called solutions. You remember that chapter, solutions? क्या होता है when you put a non-volatile solute? When you put a non-volatile solute in a solvent, what happens? तीन चीजें होती हैं. I mean, broadly एक ही चीज होती है. This is the phase diagram of water. I think ऐसा कुछ दिखता है ना? Something like that. Something like that. उसका वेपर प्रेशर गिर जाता है. So if this is 1 atmosphere, which is boiling point है, तो boiling point बढ़ जाता है, डेल्टा T B बढ़ जाता है, और जो फ्रीजिंग पॉइंट है वो घट जाता है ना? होता क्या एक्चुअली क्या हो रहा है? इट इज जस्ट वेपर प्रेशर दैट इज डिक्रीजिंग. ओके, ये भी स्टूडेंट्स रैंडमली मग करते हैं. द एक्चुअल थिंग हैपेंस, वेपर प्रेशर रिड्यूसेस. दैट इज द कॉज. द इफेक्ट इज की खैर, व्हाट्स द पॉइंट ऑफ दिस? यहां पे दिस इज नो लॉन्गर एट इक्विलिब्रियम. नो लॉन्गर, अलग कलर में लिखते हैं ताकि ये बड़ी बात है, क्योंकि नो लॉन्गर एट इक्विलिब्रियम. 0 degrees is not at equilibrium. Yeah. There is seawater, so depression and freezing point, says Ria. Okay. Minus plus 0 depression and freezing point. Okay. So the reaction goes forward. Okay. Reaction जाएगा आगे. अब एंडोथर्मिक, बट एंडोथर्मिक कहां से? हीट कहां से लेगा भाई? हीट है ही नहीं, इंसुलेटेड कंटेनर है. बट दिस इज स्पॉन्टेनियस. दिस इज स्पॉन्टेनियसली हैपनिंग. स्पॉन्टेनियसली पानी ज्यादा बनेगा. More liquid will get formed. Why? Because at 0 degrees Celsius, it is not at equilibrium. To get to equilibrium, it will lose that heat and get to the freezing point. So, where is it getting the heat from? From itself, right? तभी तो उसका टेम्परेचर लोअर होता है. एडियाबैटिक बोल रहा था ना कोई, एडियाबैटिक करो प्रियांशु. ये लो तुम्हारा एडियाबैटिक. Q equal to 0 होता है एडियाबैटिक, राइट? गुड इवनिंग जेई वाला रवि. या 12th टॉपिक्स. ओ सिद्धि फ्रॉम 11th. सॉरी सिद्धि, सॉरी. तो सिस्टम की कम होगी एंट्रोपी, 10 यूनिवर्स की इंक्रीज होगी. ओके, ऑल राइट. डेल्टा एस यूनिवर्स इज ग्रेटर देन 0. ओके, क्यू विल बी इक्वल टू 0 क्योंकि डेल्टा एस सराउंडिंग 0 है एंड यूनिवर्स एंड सिस्टम की एंट्रोपी बढ़ेगी. घटेगी क्यों यार? घटेगी क्यों? देखो, इफ क्यू इज 0 देयर इज नो हीट दैट्स गोइंग आउट. डेल्टा एच will be weird. Delta H क्या है? Delta H का concept नहीं था. Because delta S universe is greater than 0 and delta S surrounding is 0, so delta S system must be greater than 0, right? You can't have different. अगर ये plus है और ये 0 है, this must be plus, right? That's the only way for it to be plus. You see, कुछ लोगों ने बोला पहला वाला नेगेटिव होगी. Why will it be negative? जब solid से liquid बन रहा है, then delta S will be positive, right? Yeah, thanks Rabi साहब. Rabi बोलूं? Rabi? Rabi, I don't know. If it's the Rabbi wala part, then Rabbi, anyway. Entropy negative is spontaneous. Riya, nahi na? Riya, entropy positive is spontaneous. Delta G negative is spontaneous. Riya, थोड़ा सा सोचो. Delta S, अरे, Delta G is delta H minus T delta S, right? So when entropy is positive, then that affects delta G. ये तो 0 हो गया ना, because Q is 0, so forget. ठीक है? So delta E is Q plus W. Now only work is happening, Q नहीं है. ठीक है? Work क्या हो रहा है? Just whatever. Getting out. You're confused? श्लोक क्या हुआ? Okay, श्लोक. Let me go back to that. Let me go back to this. फिर से पूरा recap करता हूँ. First वाला part is okay, right? Second वाला part let's talk about. Second वाला part let's talk about. The process of solid becoming a liquid is endothermic. उसमें मुझे endothermic नहीं, sorry, it's exothermic. It's not endothermic. Endothermic होता तो नहीं, सही है ना? Solid becoming liquid is endothermic. Exactly. It requires heat. Yeah. You provide heat to a solid, it becomes a liquid. Now, where is it getting the heat from? Yeah. It cannot get heat from anywhere. Surroundings are exchange कर नहीं सकता है. So internal energy के expense पे this happens. When Q is 0, then delta E is equal to W, right? That's what we're talking about, right? So how is delta work happening? Usually think कि work gas में होता है, but when solid becomes liquid, तभी तो work होता है, right? Do you understand? And this is negative P delta V, I know. Now delta V of a liquid is going to be more, right? And yet delta T is going to be negative to make this work. Anyway, the main idea, the simple idea ये है कि ये spontaneous process है. Hence delta is surrounding, not delta is universe must be greater than 0. But Q is 0, so delta is surrounding be 0. Because delta is surrounding is always Q, negative Q of system by T. Okay, it doesn't care about anything else. It is just this. It is just this. ठीक है? Cool. श्लोक, better? Worse? इसके बाद तो एक और सवाल है. This was a starter, bro. ये तो शुरुआत वाला था. Yeah? Any doubt in this? देख भाई, जब मैं बोलता हूं कि मैं कर रहा हूं एडवांस के आइडियाज, I actually do advanced के आइडियाज. I don't beat around the bush. And these are from good textbooks. These are not things that I've made up. These questions are all from good textbooks. So you can be rest assured that there are high chances of something like this coming in the JEE Advanced exam. Conceptual ideas. Q surrounding by T. Yes, Shlok, exactly. Okay. Coping. Shlok, ping me on Telegram if you have any this thing. अगर लगता है, why am I telling IT Chem? You know where I'm at. Ping me if you feel that कुछ अजीब है या कुछ समझ में नहीं आ रहा है. All right. Cool. Last question for the day. There is another part to this. अगर ये वाला part हो गया, then I'll get to the second part. ठीक है. Otherwise, I'll give you the second part as the homework. You guys wanted me to give you advanced questions homework, right? So इसका second part we'll do as homework. We'll try and solve the first part over here. ठीक है. Mond's process आपको मालूम है? Have you heard of Mond's process? ये एडवांस में है, ठीक है, मेन में है नहीं, मालूम नहीं, बट एडवांस में है। ये जो निकेल, जस्ट लाइक what do you call this thing, there's this nickel, it's reacted with carbonyl, okay, to give you this amazing thing which is a gas. Now this is beautiful because from a solid you made it a gas, which is insane. Now only nickel reacts, rest of stuff doesn't react. So you heat it up to a high temperature, so it becomes that this thing, not heat it up, sorry, let me say ki you make this reaction go forward. I don't know, heat karo, I don't know how you'll do it. You'll make the reaction go forward. So now you have stuff in a gas phase. That gas phase, then you'll make the reaction go backward. And that's the purification process. Okay, so there's a two-step thing. Two-step. Step one is forward reaction. Step two is backward reaction. That's it. As simple as that. Okay. So you can go from this to this purity. I want you to predict the sign of delta S naught. Okay. Ria, sir, why delta S universe is positive? Yeah, metallurgy, delta is negative, nickel process, then we decompose it to get, yeah, exactly. Ria pushing, why is delta S universe positive? Ria, that's a wonderful question. Ria, for a spontaneous process, when you say that delta G is negative, delta G is T, negative T delta S universe. Okay? This is why it must be positive. After that, you get to say that delta H minus T delta S system comes from this idea. इसी idea के साथ आता है, ठीक है? I'm doing this quick derivation until you guys tell me this. आपको क्या लगता है? ठीक है, अच्छा कुछ लोग already बोल रहे हैं. Ria, there's a derivation that goes around this, okay? The actual idea is, again, people don't teach it for some reason, but delta G is minus T delta S of universe. उसको expand करके you get this. Okay, on expanding this, you get this. ठीक है? Cool. We'll deal with this later as a derivation. I've done it in the theory session. You can check it out. SN2 reaction भी हो जाएगा. What? Two step. What? That goes over my head completely. Okay, sign of delta S naught. कुछ लोग बोल रहे हैं negative, first is negative, rec, and Shlok are saying negative. Okay, let's see. Ria, ping me on Telegram. We'll talk more about that. Okay, delta is negative, says Praveen. Okay, let's see. Let's see. What do you guys think? Delta S naught is negative, positive? Huh. Okay. Cool, cool, cool. Let's deal with the first couple of things. I think delta NG is easy. Delta NG is less than 0, so delta S system must be less than 0. ठीक है, simple. Thank you. Rec. दूसरा वाला पार्ट बी. थैंक यू. फर्स्ट पार्ट ऑल ऑफ योर राइट, बिकॉज वी हीट टू रिएक्ट विद CO. श्लोक, उतना सोचने की जरूरत नहीं है. हीट की बात नहीं हो रही. मैंने गलती से हीट मेरे मुंह से निकल गया, बट हीट इज नॉट इंपॉर्टेंट, राइट? आई सेड हीट बाय मिस्टेक. हीट इज नॉट इंपॉर्टेंट. दैट विल गेट टू नो बाय डेल्टा G. द मेन आइडिया इज डेल्टा NG इज 1 minus 4, which is minus 3. So delta S system is less than 0. खत्म खत्म. सिद्धि, जब नंबर ऑफ मोल्स ऑफ गैसेस कम हो रहे हैं तो एंट्रोपी कम हो जाएगी. ठीक है? Predict the sign of delta S. Now spontaneity is dependent on temperature. What is the sign of delta S surrounding? इसमें क्या करें? If delta S system is less than 0, okay. Delta S surrounding क्या होगा? Positive होगा. Okay. Now if I want this to be spontaneous, if I want this reaction to be spontaneous, okay, think about it a little bit like this. Yeah, you're right. You guys are right. बिल्कुल सही है. Number of moles. Yeah. Cool. Great. Now, if I want this reaction to be spontaneous, which is delta G less than 0, delta H must be 0 at least at some temperature. Why? Because delta G is delta H minus T delta S. अब ये महाशय तो हो गया negative, मतलब पूरा हो जाएगा positive because it's negative. So delta H must be negative कहीं ना कहीं spontaneous करने के लिए. If I, because the reaction actually happens ना, ये तो हम लोग करते हैं. Mond's process is this. So it's somewhere. So delta S must be positive at that temperature. ठीक है? Because delta S universe is delta S system plus delta S surrounding, and ये हो गया negative. This must be positive to make this, sorry, yeah, to make this positive. ठीक है? Positive and greater than delta S system. Okay, cool. Let's go to the other three parts. Now this is where things can start to get interesting. ठीक है? At what temperature does delta G equal to 0? What is the order of K at 50 degrees Celsius? What is the order of K at 227 degrees Celsius? Now, when I say order of K, I mean 10 power x क्या है? What is x? That's what I'm asking for. ठीक है? Order. How do we do this? Yes, Riya, absolutely. Positive and greater than delta S system. I said positive and greater than delta S system because delta S uni must be positive because delta G is minus T delta S universe. Okay? And for this to be negative, this must be positive. Cool. At some temperature, hona chahiye. Okay. Now we're going to use this. At what temperature is delta G not equal to 0? I'm going to walk you through this one. You guys can go and calculate apne aap bhi kar lo, but I'll help you out a little bit. Okay. So now, ये तो था ही पहले. Okay, cool. How do we do this? Delta G not equal to 0 कैसे निकालोगे? At what temperature? Again, from first principles. What did we have here? This is positive. This matlab this whole thing because delta S naught is negative. Okay. So minus T delta S naught is going to be positive, which is annoying. Like that's a problem. That's a problem. Agar T delta S is positive, that means if I want to draw y equal to mx plus c, slope positive hai. This whole thing is positive and this is 9 c. How do you draw this graph? कैसे draw करें इसको? Can you imagine this graph? Yeah, Siddhi, you're absolutely right. You're absolutely right. H equal to Ts. That's what we're going to do. Siddhi, we're going to do that. But before that, I want to understand which direction does the reaction go if you increase the temperature. How do you know? Yeah, that's what we're getting at. This is the graph for y equal to mx plus c, jahan pe c negative hai. How do you check this? When x equal to 0, y equal to minus c. Hai na? So delta G naught is negative right here. So look at this. This is the most beautiful thing. Increasing temperature is bad for the reaction. Okay. It's bad for the reaction, which is obvious. It's because if you look at it, if you draw that thing, it's kind of obvious. Dekho, this is why I did that question pehle. Delta H naught is negative. Delta H naught is negative. So I've given you a bit of a hint. This is only going to work at low temperatures. Low temperatures pe it's going to be spontaneous. Okay. High temperature is going to be non-spontaneous. That is what we get to know from this. Okay? Okay. Siddhi, H equal to Ts. Bilkul sahi. So we are looking for this point C on the graph where delta G naught. कोई मेरा आंसर नहीं दे रहा है. मैं इतना टाइम पास कर रहा था ताकि तुमको कोई आंसर दो. Somebody give me the answer. What Siddhi said exactly? Delta H naught is T delta S naught. निकालो यार. Do this. सब दिया हुआ है. This is 30. This is 198. This is 417. Blah blah blah. It's okay. Don't do it. I'll tell you. I'll tell this. मैं आपको बता देता हूँ उसको क्या होता है. ठीक है. At temperature equal to 412 Kelvin, 139 degrees Celsius, gaya. If you increase the temperature greater than 139 degrees Celsius, the reaction becomes non-spontaneous. What does that mean, non-spontaneous? Well, technically, if you get the K values, wow, Siddhi, yes, 412 Kelvin. It's not 0.412, it will be 0.412 into 10 power 3. Siddhi, you forgot this 10 power 3. Rek and Siddhi, I know what you guys did. Rek and Siddhi, यहाँ kilojoule है, यहाँ पे joule है. This is joule per Kelvin. This is a very good point Rek and Siddhi have brought up. देखो, delta H की value is usually always in the mole units of kilojoule per mole, whereas this is in the units of joule per Kelvin. It's a very good point. इन चीज की start getting a feel for these things as well, because this will help you a lot. ताकि अगर आपको कुछ random calculation हो जाए, you'll be able to figure out very quickly. Okay. 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 Niranj, can you tell me the value? You're right, but can you tell me the value? श्लोक कहाँ गए? आंसर क्या है? कोई ऑर्डर बताओ. ऑर्डर ऑर्डर ऑर्डर. ऑर्डरिंग फूड. ओ हाँ, किलो जूल है वो. सो इस टेम्परेचर में भाई साहब बढ़ जाते हैं. ओके, लेट्स लुक एट दीज टू. आई एम गोइंग टू यूज द सेम एक्सप्रेशन हियर. या I'm going to just say कि okay, at some temperature which is 50 degrees and 227 degrees, अगर मैं ये करूँ, I'll be able to get the delta G naught values at those temperatures. ठीक है? That's what we're doing here. So I need to get delta G naught at 323 Kelvin and 500 Kelvin. How do we do that? I think we can do that, right? Let's substitute. Don't worry. I'm not going to ask you to do these scary calculations. I'll do them for you, right? I'll show you this. I'll give you these notes. You can check it out. So look at this. In Mond's process, you get, look at this. This is the difference. This is usually the energy of of a regular chemical to break a covalent bond. covalent bond की energy मतलब it's very high, yeah, very high value, 36 kilojoule. And look at that, if I go from 50 degree to 27 degrees, it literally like did a 360 flip, right? 180 flip. From plus 36 kilojoule, it went to minus 35 kilojoule. Now, what impact does this have on the K value? This is what I want you to see and appreciate. K at 323 Kelvin and at 500 Kelvin, do a bit of calculation, आपसे नहीं करा रहा हूँ, yeah? 10 power 5 and 10 power minus 4. So, in a sense, I have greater than 10 power 3 forward direction, less than 10 power minus 3 backward direction. Okay? This is what we have achieved. In Mond's process, this is the wonderful thing. Knowing all of these values, you know the exact temperature you can get to make the reaction go forward. So, initially, we heat at 50 degrees Celsius so that we convert all the nickel and 100 things. उसमें nickel निकल जाता है, gas phase में चला जाता है. Okay. At 50 degrees Celsius, you get nickel in the gas phase. We have revised the whole of Mond's process. अगर गलती से इसमें सवाल आ गया, you like thank me. Gas phase में चला जाता है, you get NiCO4. Okay. And then when you have all of it, ये सब हो गया, so you give it some time. When this happens, reaches equilibrium, you go ahead and say कि भाई और गर्म कर दो, या 227 degrees Celsius. Then it comes back and you get solid nickel, which is awesome and 99.99% pure. Okay. But this 227 degrees Celsius also is pretty hot. So there is another thing you can do. But by the way, how comfortable are you with this? अभी तक जो हमने किया है, is this okay? Give me a thumbs up if this made sense. Give me a thumbs down if this said कि भाई बिल्कुल सर के ऊपर चला गया. I don't think it's that hard. But this is just going through the motions, right? Doing maybe metallurgy in terms of thermo. Actually, if you take up metallurgy in college, it is just thermo. It is this thermo, yahi thermo, and 100 times this thermo. This makes sense. Just give me a thumbs up if you understood everything we did so far. All right, clear? Okay, great. So to recap, first step में we equilibrated the impure nickel with CO and you get NiCO4 at 50 degrees Celsius, and the K was greater than 10 power 4, मतलब always into completion, right? So you're gonna convert this as much nickel as possible into the gas phase, okay? And the reverse of this reaction happens at the higher this thing. Cool. Okay, sweet. That was it. Comfortable? Okay, good. So here is the second part of this. Do you want to do this now or do you want to do a homework on this one? Let me know. ये वाला आप लोग करना चाहोगे घर पे or do you want me to solve this for you? Let me know. I'm good doing either. करोगे? You want to spend 5 more minutes? 5 more minutes इस पे spend करोगे? Beautiful part. पढ़ लो. Now, instead of 50 degrees Celsius, we will do some magic and we'll carry out the first step at 152 degrees Celsius, but at a higher pressure, much higher pressure. You'll be like, hold on, higher pressure. What does that do? You'll solve, okay. देखो, यहाँ पे equilibrium का idea आता है. Higher pressure, हम लोग कौन सा चैप्टर कर रहे हैं? थर्मो कर रहे हैं ना? थर्मो कर रहे हैं. Okay, yeah. At a high pressure, here what happens? System tries to reduce pressure. System will try to reduce pressure. मतलब the reaction will go forward. Le Chatelier's principle. This is good. मतलब pressure increase करने से reaction जाएगा आगे. Yeah, reaction will go forward. So increasing the pressure, verifying this, I mean the variation of this Mond's process is really good. So if I increase the pressure, I can also increase the temperature to this value. Okay. But here's a small problem. If you increase the pressure, after a certain point, ये बन जाएगा liquid, and liquid is significantly harder to deal with than a gas. Now, can you imagine? You got this whole reactor set up for a gas, right? उसका pressure कुछ करना है. And suddenly, if that starts to condense and form a liquid, your life is going to be hell, because liquid is going to, I don't know, it's going to corrode stuff, it's going to react with stuff a lot, I don't know. So you don't want a liquid basically. But how do I figure out at what pressure? Can you think at what pressure can be used before liquids? How do you figure this out with this given information? Right? We have told you that NiCO4, it boils at 42 degrees Celsius. Achha. At that temperature, delta H naught vaporization is this, and assume that it doesn't change. Assume that this value is constant. Even at this weird, whatever, these things also, it doesn't change. Just assume it. Okay. अब क्या करें? Any starting point? What do you think? Just अपना सोचने का तरीका मुझे बताइए. What do you think? What do you think about this? And I just want to hear your points of view. अभी तक जो हम लोग बात की है इसमें समझ में क्या आ रहा है, क्या सर के ऊपर चला गया? Just give me whatever you're thinking right now. It's all right. It's okay. There are no wrong answers here. Yeah, please. जो मन में आ रहा है बोलो. Literally. No judgment whatsoever. What do you think? Take a minute to think about how to start this question. We need that. We need to think on this one. It's not that direct. But once you see it, you'll be like, that's what happens JEE question, right? That aha moment. अरे अच्छा ऐसा करना है. Okay. The moment you see it, you're like, अच्छा यही करना है. That's all you do. खैर, we're going to assume that इसका जो delta S naught value है, that doesn't change too much. Delta S naught कुछ है, but delta S naught doesn't change. Neurons malfunction, bouncer. Okay. Trust me, when I tell you how it's done, you'll be like, bro, really? This is it? It's going to be one of those moments. ठीक है. Sure? कुछ नहीं आ रहा दिमाग में? कुछ आ रहा है दिमाग में? सोच लो. मैंने एक रिएक्शन दिया है वहां पे. रिएक्शन मैंने क्यों दिया है? Why am I giving you that reaction? I've given you some random things. ये मैंने क्यों दिया? What do you think? What is this reaction about? That's a hint. Why am I giving you this? Do you think hack, bro? Use the hacky way. Just like hack through it. Arrhenius equation, something like that. T is given, H is also there. Opposite of reaction given. Okay. Jesse, okay. Ria is on the right track. Ria, what you said, I can get delta S naught from that. I can get delta S naught as delta H vaporization by T, right? Because that is at equilibrium, boiling of the equilibrium. So I can get delta S naught from there. If I have delta S, I have delta S naught. I can get that. Oh, I can get. What can I get? और क्या कर सकते हैं? Okay. But first step क्या है? This is a good second step. What's the first step? First step क्या है? देखो, when will this liquefy? When will this like? When the pressure is greater than K. What is K? K is simply pressure of NiCO4. Brain freeze. If K is simply the pressure of NiCO4, if I increase the pressure more than K, reaction goes backward. Reaction goes backward, right? It's like I'm rowing a boat. Row your boat gently down the stream. Merrily, 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 life is just a dream. Wow. भाई मेरा खाने वाला बंदा लेक पे है, bro. Why is he at the lake, bro? I ordered the food so long back. Bro's at the lake, bro. Tuesday. Why is he at the lake? Swiggy! What are you doing, bro? Anyway. Okay. Do you guys follow this? Everybody on the chat right now. If I increase the pressure to a value that is greater than K, then the reaction goes backward, which means that the gas liquefies, right? That's it. So I need to find K. I just need to find K. How do I get K? I can get K, right? Because delta G naught equal to delta H naught minus T delta S naught, and at this thing I can get minus RT ln K is going to be equal to delta G naught also. Yeah, and at equilibrium, बैंड तो बज ही रहा है ना सब लोग का जेई. Yeah. I'm literally singing a, what do you call this? A nursery rhyme. How Valentine's week? कुछ भी बोलते हो तुम लोग. So delta S naught की value, if you do a bit of calculation. See, in this JEE wala question, I'm not making you do these numericals. I'm solving them for you because I want you to focus on what to do. Shlok, thank you. Exactly. Yeah. So I've got delta S naught. I've got delta H naught by T. So now I say, let me now get delta G naught at 152 degrees Celsius, assuming that delta S naught and delta H naught don't change with temperature. This is standard. At school level, this is standard. Maybe you get something called steam tables, you get a lot of other things to see how it happens, but हमारे level पे this is it doesn't change temperature. ठीक है, 150 degrees में नहीं करता है. That's it. Once you do that, you get this to be negative 10.1 kilojoule. ठीक है. I have no idea, Shlok. I don't know why he's at the lake. The lake is not where the restaurant is at. I was just checking, भाई कहाँ गया है बंदा? And bro, he's still at the lake. I don't know what he's doing, bro. Lake बंद है अभी भी. 7:40, right? Khair, now my job is done. Now there's nothing left to do. I've got delta G naught. Now I can just go and substitute. Delta G naught is minus RT ln K. Ln K is some value. I get Kp to be 17.4 atmosphere. How do I know atmosphere? Atmosphere कैसे हो कैसे मालूम है? देखो यार. Or could also be bar. Okay. It is not Pascal. It is not Pascal for sure. ठीक है. So yeah, that's where we're coming from. All right. Cool, 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 like a pool, pool, pool. Because how do I know atmosphere of bar? Because देखो, जब हम लोग Kp निकालते हैं, right? You take pressure in atmosphere. That's why. If you took pressure in Pascal and you took volume in meter cube, then it would be this way, right? But that's not how it works, right? When you take क्या बोलते हैं concentration for Kc, you do mole per liter. ठीक है? This is the reason I'm going right to the basics with this one. That's why this answer is atmosphere. Kp doesn't have any units, right? The reason why I can put units to it is because this guy right here, Kp in fact is going to be P of NiCO4 at whatever pressure divided by P of NiCO4, which is 1 atmosphere. ठीक है? This thing, whole thing is called activity. ये हम लोग चीज बात कर चुके हैं in this thing. Yeah, Pascal नहीं होगा. Exactly. All right. You had evening snacks. That's good, Shlok. Thanks for rubbing it in. I'm pretty hungry right now. Thank you. Anyway, this was it, man. This was it from me. I hope you enjoyed this. Couple of questions that we got from you. Yeah. So that's the thing, right? So Mond's process, it depends on what? Volatility of NiCO4, yeah, which is a liquid at 42 degrees Celsius. So why did I do all of this with you? To prove to you that engineering is awesome. It's more than coding. It's a lot more than coding. And if you do one of these things, so now say you become a materials engineer and you go to this Mond's process and you discover new process, increasing the efficiency by 10%. You're gonna be rich beyond your wildest dreams. Like तुम्हारे अगले 10 generation के पास पैसा होगा, ठीक है? Because nickel and stuff like this is being used in batteries that are making electric cars, and that's the future, man. Tail is going to run out unless you get nuclear cars. In that case, you're going to have to do nuclear engineering. But yeah, here's some motivation for you to focus on stuff other than computer science. Core engineering, mechanical, chemical, civil, and whatnot, metallurgy and all of that. Baked samosa, no man. Baked samosa मैंने कभी नहीं खाया श्लोक. Right, Riya? All right. Yeah. Will do JEE Advanced PYQ. सिद्धि झा, मेरा प्लान PYQs करने का भी नहीं है. Because PYQs आपको 1000 जगह मिल जाएंगे, including हमारे खुद के प्लेटफॉर्म पे. You can find the PYQs everywhere. I'm trying to bring to you things that you would have never seen in your life usually. If you have seen these questions before, then you're going to crack JEE आराम से. अगर the questions that I'm doing in my sessions, if you have seen them before, you are going to crack JEE, bro. Like there's no doubt. ठीक है. But it so happens that students solve a lot of questions and they don't solve these things that test the basics. They solve a lot of quote-unquote hard questions, but not these kind of things. So my focus is going to be to get you questions like this, subjective questions that make you think. I'm not going to be doing any JEE Advanced PYQs because JEE Advanced PYQs करने कोई फायदा है नहीं. And that's the problem. You know, people solve JEE Advanced PYQs और वो theory को मग कर लेते हैं and they hope कि उससे JEE Advanced clear हो जाएगा. उससे कभी नहीं होगा. कभी नहीं होगा JEE Advanced PYQs करने से. JEE Advanced PYQs are a good way to test where you stand. आपने पहले कभी देखा नहीं है? You try and solve it. If you're able to solve it, that's a really good test of that. But otherwise, yeah, that's this is my thinking. Please बुरा मत मानना. ठीक है. Okay, anime hub. Cool. Up to you, bro. How can I decide that for you? Anyway, thank you so much for your time. I overshot this like way over what I had planned. But you know me, I like thermo. So आपके ऊपर भी ज़्यादा डाल देता हूँ thermo. Hub, bro. What do you want me to say? I've addressed you. What do I have to like put you in a timeout, dude? Replace pinned message. No, I don't want to pin your message. I'm going to put you in a timeout for like just 1 minute so you just calm down a little bit. All right. Thank you, everybody. Thank you, everybody, for your time. I'll see you on Thursday. And apologies for a slightly lamba. Yeah, exactly. Shlok, that's a very smart thing to do. You got to attempt JEE Advanced questions as mocks. If you're going to try and solve them, and see, it's good to know how they're solved, and that'll help you a lot in the JEE Main exam. But for the JEE Advanced exam, you have to study these kind of questions. And I'll be very upfront with you. If you find these kind of questions to be very difficult, यार it's okay. Focus on a different exam. कोई चक्कर नहीं है. अपने don't take this on your ego. यार JEE Advanced सवाल नहीं हो रहा. नहीं हो रहा यार. क्या फर्क पड़ता है? It's okay. There are many other things to do. Spend your time judiciously. Have realistic goals. Yeah, I'm here to support you either way. Whatever you want to do, you can find me on I Teach Chem on Telegram and Discord. Chalo, see you. Thank you so much, everybody, for your time. Bye. On Thursday. All right. See you. Bye. 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 See you, everybody. You want to see the timetable? Hold on, Siddhi and everybody else who wants a timetable. This is the timetable for next couple of weeks. If you are giving the JEE Main exam, please attempt the NEET sessions as well. They are going to help you a lot like these sessions are. In fact, अगर JEE Main आपका focus है, do this and that. You must. So you must. It'll be good for you if you do. You must not do anything. There's nothing you must do. If you do it, it'll help you. ठीक है? Thank you so much for your time, guys. Bye. Good night. Yeah, it was fun here too. Bye bye. See you. Tata.